everyone. I hope you're well. I'm going to go over Venn diagrams and tables in this video. So this is on the lesson with Venn diagrams. I believe it's it's example 4 if you can see that. So the first example I'm going to go over says on an online bookstore, suppose that 62% of the books are fiction, 47% are ebooks, and 14% are ebooks that are not of works of fiction, and a book will be selected at random. So the first thing I'm going to do is make a little note to myself. I know that 0.62 is fiction and 0.47 are ebooks. We also know that 0.14 are ebooks, but not fiction. A book will be selected at random. So what this means is that 62 is this whole circle of F, and 47 is this whole circle of E. With a Venn diagram, it's not that I'm going to put 62 here and 47 here. I need to remember that there's an overlap that I have to keep in mind. And this guy right here, the 0.14, is going to help us. This says it's an ebook but not fiction. That would go right here on the Venn diagram because it's an ebook, but it's not overlapping with the fiction area. Now, because I have that, I can do a simple subtraction. I know that this whole entire circle is 47%. If I take away that 0.14, or 14% if you want it as a percent, if I subtract 0.47 minus 0.14, I will get the value of the overlap, which would be 0.33. And that's what's going to go here. Let me just make it bigger so we can fit it nicely. 0.33. Okay, so now I got my overlap, I got my ebook, and I have one more right now. I got to remember that this whole entire circle is 0.62. But we now know that the overlap is 0.33. So I'm going to do 0.62 minus 0.33. And when I do that, 0.62 minus 0.33 in my calculator, I get 0.29. And that's what's going to go here. Now you have to remember, all these probabilities need to add up to 1. So I'm going to do 0.29 plus 0.33 plus 0.14. I'm going to see what I get. So 0.29 plus 0.33 plus 0.14. I end up getting, oops, that was wrong. Let me do it one more time. 0.29 plus 0.33 plus 0.14. When I add that up, I keep typing in 7 for some reason. Okay, 0.76, which is not 1. So that means that there's a value that goes on the outside. To find that value, I have to remember that the whole entire square needs to sum up to 1. And what happens on the outside is the books that aren't fiction or ebooks. Okay, so what we're going to do is we're going to do 1 minus 0.76, and we will get a value. 1 minus 0.76, and that'll get me my value of 0.24 on the outside. Okay, so this Venn diagram is going to help me analyze my data. Venn diagrams are a great way to visualize probabilities. And when in doubt, I always say make a Venn diagram as a visual if you're lost in a problem. The first question says, find the probability that a book will be a work of fiction and an ebook. That's the intersection. That's the both. Remember, this is the symbol for and. Okay, so that's actually right here. That is your and, the overlap. So we're going to write 0.33 as our answer. Neither a work of fiction nor available as an ebook. So that means that it's not fiction, it's not an ebook. That's the guy on the outside. He doesn't involve these two circles, so that's going to be 0.24. And without the Venn diagram, it might have been a little, difficult for me to find these values. Now, what's also nice with a Venn diagram is you can make it into a table. And the table is nice to also visualize your data. First off, the total of all these should be 1 because it's probabilities. Second off, I know that the total amount of fiction books is 0.62, so I can put that here. And I know the total amount of ebooks is 0.47. I also know that the amount of ebooks that are both would be the crossing of that. So here's ebook and fiction. So if you can visualize it, they cross here, and that's where the 0.33 goes. Okay, but now what about this guy on the outside, this 0.24? That's not an ebook, not a fiction, so not an ebook, not a fiction. That goes right there. So that would be your 0.24. Now all you have to do is do some subtraction. So if you subtract 0.47 minus 0.33, you will get 0.14. And you're going to keep doing that until you fill in the rest of the table. 0.33, because it's the total, minus 0.62 minus 0.33, you are going to get 0.29. Okay, let's keep going. Add these together to get my total here. We get 0.38. And then I'm going to do either add these or do 1 minus 0.47. This actually looks like a 4, so I'm going to make that a 9. Okay, and you'll end up getting 0.53 here. Okay, and there we go. So example 5. When a fish is selected at random from a tank, the probability that has a green tail is 0.64 and the probability that has a red fin is 0.52. They want you to draw a Venn diagram. So we're going to make ourselves a Venn diagram. So we've got to make our own. They did not give us one. That's fine. First off, always remember your box. Make your 2 circles nice and large so that you can fit everything in. Oh, that was very misshapen, so I mean, not that it really matters, but I also like to draw the lines 1, 2, 3, and the one on the outside, so I know that those are the values I need to fill in. Now I got to think about my variables. There are 2 variables here. There are fishes with green tails, and there are fish with red fins. Okay, so let's see what we got. They changed the probabilities from percents to decimals already, so we don't have to convert anything, but we are going to start filling in. They say that 0.64 is the probability that has a green tail. So I'm just going to write on the side 0.64 equals the green, and red fin is 0.25, and both is 0.19. Now when you're given both, that's a gift. You want to put that on the Venn diagram right away. So 0.19 right in the middle. Okay, 0.19 in the middle. So now I can use that to find the other values. I know that green would be this whole entire circle. This whole entire thing is green. So this plus whatever this number would give me that 0.64. So all you have to do to get this value on the inside is do 0.19 and take that away with the 0.64. Subtracting that will get you the 0.45. Same thing here. The red fin, we know the whole entire circle there is the red fin. So again, I'm going to have to do this whole subtracting the 0.19. So 0.25 minus the 0.19. And then you're going to get a value of 0.06, and that goes in here. Now again, the Venn diagram has to add up all the way to 1, because probabilities, everything sums to 1, which represents 100%. So when I add these 3 values up, I should get 1 if I was done. So let's see, 0.45 plus 0.19 plus 0.06. I end up getting 0.7, which is not 1. How much is left away from 1? 0.3. So that's what's going to go outside here. Boom. Okay, so now we can answer our questions. What's the probability that the fish has red fins but does not have a green tail? So let's look. Here's my red fin, but we do not want a green tail. So that means I don't want this. We want just this 0.06 value. So 0.06 is that answer. Next question says a green tail or red fin. Now if you remember in the previous video, or is the sum of all the 3 things, just the inside of the circle for a Venn diagram. It's very easy to calculate. For Venn diagrams to get or, add the 3 numbers inside the Venn diagram. So I'm going to do, just to show you, 0.45 plus 0.19 plus 0.06. And we got this value already, it was 0.7. The last one they want is neither a green tail nor a red fin, which means that it's not at all in the circles. So we don't want here, we don't want here, we don't want here, because that's both. It's this guy on the outside. 0.3 or 30% don't have either. And again, like the previous problem, I can make this Venn diagram into a table. So again, I always make that 1 because it's going to add up to 1. Our both is 0.19, and that's where the red fins and the green tails intersect. So I'm going to put that here because that's both. Now, how many have red fins? We knew that 0.25 had red fins, so I'm going to put that 0.25 here. How many had green tails? 0.64. Okay, so I'm going to put 0.64 right here. Now, actually at this point, I think you have enough information to just subtract and fill in the missing boxes, but we do have more information. We know that point 3 is on the outside, which means that it's not a red fin, not a green tail, so that goes here. And then I'm just going to subtract. So if I do 0.64, subtract 0.19, I get 0.45. And if I do 1 minus 0.25, we get 0.75. And I always double check that this plus this does equal that, which is true. And this plus this does equal 1. 1 minus 0.64 will get us the other guy, which is 0.36. And then 0.36 minus 0.3 is 0.06. And there's your table. Okay, so we're going to go over the addition rule on this slide. So the addition rule allows you to add events and subtract their overlap. We use this rule when we see the word or. Okay, it is a rule you have to memorize, but you know, you guys are always going to have the chance to look it up. So for the regions, though, you do have to memorize it. All right, so the addition rule is used for calculating the probability of the union of two events. Union means them together, or. So the addition rule calculates P or A or B, the probability of the sum of A and B minus the overlap. So you always want to take into account that there could be this overlap right here. We do not want to double count. The double counting mistake is a huge deal, so we always want to make sure we use this subtraction there. Okay, so let's do a problem. It says when a car is bought to a repair shop for a service, the probability that it needs a transmission fluid is 0.38. So actually the questions here ask you that, so I'm just going to put that right next to it. The probability that it will need the brake pads fixed is 0.28, so we'll put that there. And the probability that it will need both is 0.16. Let the event that a car needs transmission fluid be T and the other one be B. They want you to use the addition rule to find the probability. So I'm going to use my values. I want the probability that it needs transmission fluid or brake pads, so T or B. So that means I'm going to add because I see the word or. Or means to add in probability. And subtract the overlap. Always remember, subtract the overlap if there's an overlap. Plus the brakes, subtracting my overlap of P, of T, and B. Okay? So I'm going to put 0.38 here, plus 0.28 here, minus 0.16, and I will get 0.5. Boom. Now this is an example of an event that is not mutually exclusive. Mutually exclusive events are events that have the Venn diagram separate, meaning that there is no overlap. So if something was mutually exclusive, it would not have this overlap. This example is not mutually exclusive. It has the overlap. We have to subtract it. But when you see something disjoint or mutually exclusive, look at the picture here. The Venn diagram is clearly separate. There is no overlap. And when that happens, the formula can be shortened to just P, A, and B. Well, P of A plus P of B, without that overlap part that we have in this guy right here. But I will tell you that I always add it on no matter what, because if there was an overlap, this would just be 0. If there was not an overlap, that would just be 0. So it really doesn't matter. It doesn't really affect the problem, and I think it's nice and easier to memorize one formula rather than two. Okay, so we have a set of cards in this problem. It says that there are, I'm just going to make a little picture over here. There are 10 black cards. Let's write in the same color. 10 black cards that have squares, 10 black cards with circles. Let's change color. 10 red cards with X's and 10 red cards with diamonds. They say a card will be selected at random, and they want the probability that her card is black or shows diamonds. Now let's see. Or means to add the two probabilities and subtract the overlap if there's an overlap. Hold on, let me just erase that. Okay. Okay. So probability of getting a black card. Well, there are 20 total black cards in this deck out of 40. So that would be 20 out of 40. Plus the probability of getting a diamond. There are 10 diamonds out of the card deck out of 40. Minus, are there any cards that are black and a diamond? No, there are not. So this is an example of 0 over 40, which is what I was saying before. That just becomes 0, so it's not any harm done. I add this together, I get 30 over 40, which is 3/4 if you'd like to simplify. All right, now let's do the next one. Find the probability that a card has red or an X. So, or means to add the two probabilities and subtract the overlap if there's an overlap with that and. The and symbol means the overlap. So let's think. How many red cards are there in the deck? Well, there are 10 X's that are red and 10 diamonds that are red, so there are 20 out of 40. How many X's are there? There are 10 out of 40. And are there any cards that are red and an X? Yeah, right here. There are 10 out of 40. And that gets you just 20 out of 40, which reduces to 1/2. Now, I could have probably thought that out on my own, but the formula is useful, especially for more complicated problems. So the rule of thumb is that when you see or, you must add, and always look out for an overlap. So if there's an overlap, you want to make sure you subtract that overlap so you do not double count. And that is all. I hope you guys are well, and I'll see you soon.